So now I am requesting Damisha ma'am to kindly start this webinar, please. Thank you.
Thank you, Rohit. And good afternoon to all of you. Welcome to this next series of the webinar, next lecture of the webinar. And every time I always say, but I don't get, I am not, tired of saying that this is a very good initiative by Government of India, the Azadi Ka Amrit Mahotsav, where we are celebrating 75 years of our independence, and of course, the glorious history of people, culture, and achievements. Today I was reading that it is a festival of awakening of the nation. The nation has been awakened to this, that we have to now move towards fulfilling our dream of being a global power, of global, for global peace and development. The G20 summit, or the activities of the G20 summit, they are a testimony to this, that we are all working towards global peace, and we want the the betterment of the entire world, the concept of life. And here we have, under this Azadi Ka Amrit Mahotsav, a lot of activities. The campaigns have been launched, and these are all outreach activities. These are activities where we have to show that yes, India is the first to reckon with. We have already reached the moon, and I think this is also one achievement which comes as a part of our Azadi Ka Amrit Mahotsav. So in Skill Council, we decided that we should connect with our learned people, and we should, encourage the dissemination of knowledge, and of course, learn ourselves. And in various sectors like where we are working, we should connect, we should learn more, and we should spread this awareness, knowledge through our webinar series. So we started this webinar series, which was initially labeled as 75. I was reading the 12th March, this was launched, and we started in September, and we have completed more than 86. Now it is the 87th today. And we are doing this in all the sectors, in environment, renewable energy, waste, water management, sustainability, net zero. We have covered all sectors, and we have learned a lot from our learned speakers. So today we have a very, important topic: clean cooking. Clean cooking is something. Cooking is a very, internal or activity with every household in the world. Cooking, we have to cook. We have to cook to keep ourselves, to sustain ourselves, to eat the food which we require for our activities. But there is a method of cooking. The way it is cooked is something which is not healthy, or it is it is not it is creating an adverse impact in the environment, on the woman who cooks. We have about 60% of our population who are still using biomass, open traditional cook stoves for cooking, and this is impacting their health. We have so many millions of deaths due to indoor pollution. So this needs to be curbed. And I have, from the very beginning of my career, have started with clean cooking only, the national program on improved chulas. So, but what I feel is that initially we used to take it as a developmental activity. We are saying there are health impacts, there are environment impacts, and we have to see that we can do more economic activity, save time for the woman who cooks the food, and of course the safety also. But now the concept is more towards the product. It is more of a product which is being now promoted. Business development is there. So that is why solar also has come into it. Solar based cooking is there. So this sector is getting a big push. And I feel today, when we listen to Dr. Raman, we will really know how this sector has really moved from the, the cemented or the cook stoves which we used to construct in the houses. They were known as clean cook stoves, but they didn't have that impact because it was more of a traditional activity which we were doing. But now the product is, it is in the form of a business development. It is in the form of there are manufacturing companies who have come up with, electric cooking, and they're also solar-based cooking. So all this is leading to our meeting our goals. We have to meet the goal of 2030 for universal access to energy, clean energy to every household. So Dr. Raman, today we in our Skill Council also, the first thing I did was to develop training modules for clean cooking. So we did develop, and we have been doing trainings, but they're very minimal, because this product as it is, the traditional one is still there, but the other products have not been so successful. We tried one pilot in the Haryana villages. We were successful in, introducing electric cooking there, the prestige model, in almost 65 villages. And it was quite successful. Everyone adopted it as one of the means. So I feel this is a sector which is going to get a more push, and we need to learn from. And we are very fortunate to have Dr. Raman with us, who will tell us more and more on how we can diversify and really bring this as a part of our life for, cooking our energy requirements. So I welcome you, Dr. Raman, and I'm really looking forward to connecting with you and listening to you for your detailed, lecture. And of course, you're also connected with clean cooking since long as I am. Thank you once again, and I welcome you. I would
Thank
now
you very much.
request Mr. PB Singh to kindly introduce you. Thank you once again.
Thank you, ma'am. Thank you very much for welcoming the speaker and other participants. Good afternoon, everyone. I'll welcome you all to the 87th series of the webinar. The Skill Council for Green Job is organizing a series of webinars to celebrate Azadi ka Amrit Mahotsav as a part of India's celebration of 75 years of independence. In this series, SCGJ is inviting eminent and learned speakers in different sectors on sustainable development, renewable energy, and waste management, so as to deepen in the understanding of recent development in these sectors. The first in the series was launched on 24th September 2021. Today we have Dr. Raman, Director, a very experienced learned distinguished speaker who will be sharing his expertise and experience on solar cooktop using concentrate, solar collector, and hybrid thermal storage system, a potential option for clean cooking, features, status, and way forward. I would like to share his brief profile with all of you. Dr. Raman has done his doctorate from Pondicherry University on syngas production through biomass gasification and its application for power generation, industrial thermal applications, and transport sector. Presently, Dr. Raman is the Director of Energy Efficiency and Environment Private Limited, New Delhi, having more than 40 years of experience, acquired a strong subject expertise on renewable energy technologies. Dr. Raman has extensively worked on several renewable energy products in the area of biomass gasification, biogas plants, solar pumps, solar concentrators, and solar cooker. Dr. Raman contributed to more than a dozen patents on the invention of renewable energy products like biomass gasifiers and clean combustion cooker stove. Authored more than 100 publications, which include publications in reputed international journals. Dr. Raman designed and developed forced draft biomass cooker stove integrated with TEG for small power generation. Recently developed an advanced 3-stage biomass gasifier system for power generation and got it patented. Worked in the many international projects in the continents of East Asia, Africa, Europe, and Australia. Presently, Dr. Raman focused research are design and development of biomass steam gasification system to produce hydrogen-rich syngas for production green hydrogen. Secondly, development of clean combustion cooker stove using biomass with integrated porous radiant burner. Thirdly, development of innovative solar cooktop using concentrated solar collector with hybrid thermal storage system. Now I'm requesting Dr. Raman to start the presentation. Over to you, sir.
Thank you very much, PVC.
Thanks, sir.
Thank you. First of all, I would like to thank to SC Skill Council for Green Job and for giving me the opportunity to talk on this clean cooking subject, because this is one of the important subject, and it's directly linked with the human health and welfare and all those things. So, so I thank you everyone, and I'll start this presentation. I think the screen sharing has to be given, or should I share it again?
Yes, no, sir. You have to share it again, sir.
Okay, just 1 second.
Yes, it is visible, sir.
Okay. Just 1 second. Yeah. Just 1 second. See, when we talk about the clean cooking solution, then I thought selected the topic on solar cooktop, because solar cooker was very much famous. That is a box type solar cooker during 80s and 90s, and later it was slowly gone away due to several setbacks with that actually. And then not much is happening, and here and there are small applications are done using the solar cooker, and somewhere people were using the solar concentrator for community cooking kind of this thing. But in domestic side, not much was happened. Then I selected this topic, solar cooktop using concentrator solar cooker and hybrid thermal storage system, a potential option for clean cooking. Feature, status, and way forward. I will discuss this thing on the 3 categories. And if you see that solar, everyone knows that it has several how to say challenges, because though it is free energy and it available for a certain time, and we have to match our cooking time with the radiation available. So that is one of the thing. And so there are several advantages and disadvantages also with the existing technologies, because that's where we have to identify the challenges and overcome it. I put it in the topic, the features and advantages and the status of the existing technology and way forward to overcome those things, and how can we go in a large way using solar cooktop and solar energy for clean cooking applications. Here, the outline of the presentation will be like this actually. So I won't directly get into solar, because I will go with the status of the other practices also done, and what is the advantage, why solar kind of this thing. The introduction is with starting with the need for clean cooking. So what is clean cooking and why do we need it actually, and how clean we can go for, that kind of discussion we can have. And then the cooking practice, existing cooking practices and options to select the cook stoves. There are several type of cook stoves with several type of energy source are available. And so we will discuss briefly about those things, that they are the biomass cook stoves, LPG cook stoves, and electric cook stoves, and solar cook stoves. And within solar cook stoves, I added one more thing is the solar cooktop. This is the advanced one compared to the conventional solar cook stoves. And we'll discuss about the features of solar cooktop, and also about the advantages of the solar cooktop. The status of the technology, particularly, where do we stand in this with the technology of solar cooktop, and how long it will take, and what is the one stopping it, why it is not taking. Those things we can cover to some extent in this presentation. And we also will see the existing types of solar cooker, and we will see the challenges and why they were not taken, and why they were adapted in a very smaller scale. So here, also we'll focus on this role of policy, because there are several policies on cook stoves. Earlier for biomass cook stove, then the policy came from the LPG part, and there are also policies for the electric cook stoves. And so how the role of policy in promotion of solar cooktop will be there. That's what another aspect which you will see. And conclusions, just to summarizing some of the key points. when we start there, why do we need the clean cooking? What is the problem with the existing cooking? So they are the little bit things which we need to understand before getting into very much detail on this solar cooktops. And though it is a common fact and some of the numbers most of us know, but still I have just put as key points here actually. And that is the more than 2.6 billion people do not have access to clean fuel and rely entirely on biomass to meet their daily energy needs for cooking and heating. See, when we say the large population is adopting the biomass to cook, means it is not by choice or anything. It's basically the economic factor. The fuel cost, if you see the rupees per kilocalories or the useful energy, kind of the energy cost, when we see the biomass energy is the cheapest one and it's affordable. And even the cook stove also, even if the people put 3 stones and start cooking kind of this thing. So that's how these biomass cook stoves are largely used. It's not because of other reason. What I could see is basically on the economic, and economic status is the key influencing factor here for the 2.6 billion people to use biomass cook stove actually. Earlier, Kurt Smith used to have an energy ladder actually, basically on the clean cooking point of view, but that also has a strong correlation with the economic of the people who use, and then the energy ladder who use which energy, depending upon the affordability actually. So traditional cook stoves are currently used to burn biomass fuel, often lack of fuel efficiency and result in incomplete combustion. This incomplete combustion is the key word actually. This is the one has to see. Every fuel has a different combustion property, and biomass has its own combustion property. Combustion properties are generally known as the, apart from calorific value, the ignition temperature, flame velocity, flame propagation, like that. There are many things are there. And also the air requirement, how much air we have to give and how do we distribute the air in it actually. So sometimes biomass often called as the poor combustion fuel kind of this thing, but it's basically, it's not the poor combustion fuel, but it's all depends on the what kind of combustor we have, the technology status actually, how much we could design and what is that we have. So whatever we have, depending upon the thing, the combustion efficiency as well as the combustion efficiency and the emission factor, they are interrelated actually. The poor combustion will give more emission, and good combustion will give less emission actually. So so combustion is a very key word, a lot of attention to be given to combustion and to develop a good combustor. That is another this thing. Here we will focus on the status on the biomass cook stove. So that is due to incomplete combustion, the biomass cook stoves pollutes more actually. And efficiency, again, if you see efficiency and emission, they are two different identity. Even if you have a good stove with too much efficiency, good efficiency, and if it gives more pollutant, then again the stove is not, we can't name it as a good stove because of the emission factor, efficiency, this both has to go together actually. We have, any stove should have good merit on both of this factor, efficiency and emission. And yet exposure to fine particulate matter, such as for particles that less than 2.5 mm in size, toxic gases and untoxic gases like carbon monoxide are not good for health actually. So they can cause a different type of disease. There are several studies, several reports. So so when one side, what happens is in the economically poor people, when they use the biomass, and one side no money to buy the fuel or anything, and again when they fall on ill, then again additional expenditure on this. So health, comfort, and wellness, all this thing is directly linked to the clean cooking options, because there are several studies has been conducted on this thing, particularly women and children health, who is there in the kitchen, particularly for spending more time in the kitchen. So even there are some studies, actually, there are a lot of even, how to say, the arguments discussion goes on the how these numbers are valid, but how whatever it is, the reported number is like this: 2.3 to 3.8 million deaths results from illness or due to the household air pollution. And the household air pollution means basically the polluting equipment in the household is the cook stove, actually. So inefficient use of biomass fuels and kerosene during cooking makes a lot of health impact, particularly. See, when we talk about clean cooking, what all the option we have in the hand, actually. One is the biomass cook stove. And in biomass cook stove, there are two categories we can call. One is the conventional cook stove. Even now, largely, if you see in my basic or in my experience, wherever I visited in African countries or India, wherever it is, and even in East Asia also, at least I can see is more than 70-80% of the cook stoves are conventional biomass cook stoves. And improved cook stoves also there, but it's limited in use. Why? There are also some factors. Improved cook stoves demand certain things like power or some other small electric power to run a fan. Improved cook stoves generally known as small gasified cook stoves also, actually. So what happens is the cost of conventional cook stove, cost of improved cook stove, there itself it comes the choices to go for conventional cook stove. So everywhere the cost, the economic factors affects actually the choice of selection of cook stove. Then next to biomass cook stove, we have LPG or PNG cook stoves, mostly used in urban areas. And then the solar cooker. Within solar cooker, there are different types. One is the box type, another is dish type on concentrated cookers. A solar cooktop, that is the one which we will be talking more about it in this presentation. That is the upcoming technology. And so far, I have not come across this such type of solar cooktop apart from the electrical one, particularly. Solar cooktop using thermal storage, particularly. And then lastly, the electric cook stove, e-cook stove, solar power. It can operate either by solar power or grid power. We will talk in detail on this thing, electrical cook stove, because solar power is the clean cook stove in the kitchen or outside the kitchen also. But the grid power, somewhere or other, if the power is produced from coal, the emission is somewhere and the cleanliness is in our kitchen. So this is the difference which we have to see this thing. Basically. When we talk, go a little bit detail on biomass cook stoves. In India, about 32% of the total primary energy use in the country is still derived from biomass. More than 70% of the country's population depends upon, maybe the number might have been reduced a little bit here and there, at least around 70% of the country's population depends upon on it for its energy needs. Actually. Currently, the availability of biomass in India, this is the one thing which we have to note actually, is about 750 million metric tons per year. It's a very large biomass potential actually. So all are not used for cooking application, but this is the biomass potential available here actually. The clean and efficient cook stove can enable to have a large biomass potential available for other use like power generation. When a conventional chula consumes 1.5 kg per person per day, the improved chula consumes 0.55 kg per day. That is almost equivalent to more than 50% of the fuel saving. If we save this fuel, that biomass can be used for gasification and power generation. So use of improved biomass cook stoves can give access for clean energy in the village, not only for the cooking, but also for clean energy like electrical power generation for lighting and other domestic. So it is very important to go for clean cooking with higher efficiency and allow the biomass to use for other applications like power generation. There are many improved cook stoves work with a good efficiency, but the emission factor need improvement, because there are reports, there are more than 100 or 150 improved cook stoves models, because there is a book published, and we can see that more than 100, 150 models of improved cook stoves are there. But the thing is, efficiency wise they are improved, emissions wise they are improved a little bit, but still there is a lot of scope to improve the stove to reduce emission, actually harmful emission. Here we can see this is one of the things, the standard. When we talk about clean cooking, the performance standards and rating is there in place, actually. It's there in place since many years. And now people are working, taking this one as the baseline, actually, as the reference point. What happens is, there are different kind of, if you see in the left-hand side column, we can see that thermal, addition to the thermal efficiency, the CO, particulate matter, and other emission factors, including safety, is given a rank, particularly given a point with as a reference point. So the cook stoves, any cook stove can fit in this table where it stands, actually. Generally, conventional cook stoves, the 3-stone fire, they take it in tier 0, and cook stove like LPG or PNG cook stoves goes in tier 4, actually. Maybe electric cook stoves are much cleaner, and they may go beyond the tier 4, particularly. Here we can see that cook stoves, the rating emission is given in high power and low power, because the combustion rate influences the emission factors. When the cook stove is put at the higher high power, then the emission rate is different, and at low power its emission rate is different. Particularly biomass cook stoves emits more harmful gases when it is in the lower power, actually, because of the low temperature of the firebox and all. So there are several factors. So this is the one standard which is followed across the world. So the effort is to make the biomass cook stove as good as LPG cook stove, to take it to the tier 4, actually. Some of the stoves, when I told more than 100 cook stoves are there, improved cook stoves are there, but still a focus to be done on the efficiency. These all are the improved cook stoves. One is rocket stove, another is gasified stove, and charcoal stove, LPG stove. If you see the biomass cook stove, the first 3 rows are related to the biomass cook stoves. They fall in tier 1, 2, 3, but they could not go to tier 4. Only LPG cook stove meets the requirement of the tier 4. So now the effort has to be put for clean cooking in the biomass cook stove, how to take it to the tier 4. So that is still remaining. This is the status of the biomass cook stoves. And some of the figure we can see here, the 3-stone fire. In Africa, any house, when we see in front of the house, we can see this 3-stone, actually. Very big stone, big vessels and all. And in India, we can see this type of conventional cook stove, and this small gasified cook stove, one of the improved cook stove. It has a small fan, and it gives much cleaner gas and good efficiency. And this also another improved cook stove like rocket cook stove. There is no fan, but it works based on the natural draft. And this is the cook stove which we are working at our office in EEPL. This is one of the most advanced biomass cook stove with high efficiency, lower emission, and also it can generate power, actually. There is TG, thermoelectric power. When I was started this work around 2010 to work on thermoelectric power generation, it is very difficult to TGs, and TGs are very much expensive. Now there was a tremendous cost reduction. It's easily available. So in future, this is one of the future cook stove, and still we are working on it, on the studying efficiency and all those things, emission factors. So here what happens in the top, we can see there is a porous radiant layer is there. So this is known as porous radiant burner, and this one filters the fine particles. Also it radiates the heat directly to the vessel. So efficiency is good, and emissions also will be much lower, actually. So this is one of the a new area, and the biomass cook stove research is going on. Now, when we go to the second option about the LPG cook stoves, actually, the scenario of LPG cook stoves are like this. 13% of the total petroleum product consumption is used for as LPG, actually. Household consumption out of the 13%, 90% of the LPG is consumed by households. A very large fraction, actually, is going for the household cooking, actually. Industries use 8%, and transport sector use around 2%. And there is, if you see the last row, the LPG consumption grew up by over 84% from about 15.3 million ton to 28.3 million tons. See what happens to one side, we are talking about net zero emission and offsetting the conventional fuel and all. And this is not a good trend, again, to increase the conventional fuel consumption. But at the same time, anyway, due to the cost, as I told since the beginning, the economic factor influences the choice of fuel and cooking options. Due to the economic factor, now a small reduction is there. Exact number still we have to see. Anyway, this is 21-22 data. Clean cooking using solar will reduce this kind of data, because it is very clear 90% of the LPG is consumed in household. Means when we put a significant fraction using this clean cooking solar cooktop, and a large portion of the LPG can be reduced. So this will give a clean cooking environment in the house, as well as it also will have an impact on the climate change, actually, to avoid the carbon emission. This is one of the things, the influence with the cost and the subsidy part. The dark blue line is about the LPG one. There was a big peak when there was a policy, and there was large scale dissemination of the LPG cook stoves and cylinders and all. There is a big peak during that program, and then there was a fall based on the cost again, actually. And so what I want to say is the policies program, they influence a lot cooking options and cooking fuel, all these things. So policy and policy subsidies and its cost of the fuel have a large influencing factor on selection of cooking options, particularly. LPGs, in the earlier slide, I have shown that there are 0 to 4 tires, totally 5 tires. Out of that thing, that fourth tire was that LPG is shown as the cleaner combustion. But still, beyond that table, LPG also have different other kind of pollutants. So if you see here, the NOx pollution is listed here, depending upon the different kind of cooking food, and that how much the emission would be. And again, in addition to that NOx, LPG also has the emission factors like xylene, toluene, and ethyl benzene. Benzene is one of the carcinogenic component, and so this is the reason now a lot of Western countries are shifting from LPG to electric cooking, actually. I think in several places in US and UK and still some other countries already, they're shifted already. So maybe in India also this situation may come, because earlier pollution from LPG cook stove was not talked much. This was a recent years development. So this is the one use more attention towards the need for clean cooking. But right now, people take the option as the electrical cooking, actually. So beyond electrical, maybe the best option is that solar cooking, actually. So that's why I thought I have selected this subject, then at least to put it forward, then many people may get in, and our future, we should be able to see more solar cooktops, actually. So the key message of this slide is LPG also has a lot of emissions, harmful emissions, and it needs cleaner cooking beyond LPG. Now, based on that problem related to the biomass or the LPG cookings, e-cooking is being introduced at many places. Even in India also in February 2021, actually, the government of India launched the Go Electric campaign actually to create mass awareness about the benefits of e-cooking devices. So there was some program, some projects here and there, and still there is a long way to go as far as the electric cooking. One is the cost of electricity, and again, if you go for PV, again the cost. So, but a continuous effort, when the scale is more, the cost can come down actually. The Power Ministry also plans to develop an aggregation model for electric cooking system to promote its adoption by making it affordable and to cover as many households as possible by 2030. There is a target. Say that's what one side we have a target and the policy, and the policy should be effective and conducive to achieve the target. Actually, the gap between the target and the achievement should be minimized actually. So that is another thing. So e-cooking, there is a policy in place and targets in place, but similar thing is needed for the solar cooktop also. So some of the figure I put, e-cooking means induction cookers actually. There are several electric cookers are there, but presently most of the thing when we say e-cooking means it's a pressure cook and the induction cooker. And induction cooker has several advantages. All are touch buttons. We can see that because nowadays there are induction cooker even with the 2 parts also actually. And even nowadays, another thing which most of us could have, the LPG cook stoves integrated with the induction cooker also is there in the market actually. So people have their choice either to go for electric cooking or induction cooking. Another e-cooking is with the PV and battery storage. So this is another thing commercially available in India also. The cost is closer to 65 to 70,000 or something, but I don't know, somehow or other this should be taken off, but maybe the cost when we go for electrical cooking using this kind of model, it has a maintenance of the life of PV and the battery actually. Life of the battery is the one, the maintenance after a certain period. But if you go take the thermal route, then we don't have too much after installation expenditure on maintenance part particularly. Now we will go to the solar cook stoves actually. Let's say I told in the beginning during that outline slide itself, the solar cook stove we categorize in two type. One is that box type cooker and another is the cooker with the concentrated one, the dish type cookers actually. At first, most of the cook stoves are designed to cook in the open area. Again, the biggest drawback of the existing solar cookers are they are put either in the outside the house, either in the front of the house or in the terrace actually. So that is another thing. So people has to go out actually and then cook for thing in the sun. So that is another thing. The solar radiation receiver is integrated to cooking vessel actually. So in the concentrated cooker, it is like that. And a solar cooker can be used only during sunshine hours, actually. So that is another biggest. So we don't have any flexibility. Whenever the peak radiation is, we have to go and stand outside and cook it. So that is another reason. So these all are the challenges. Only the or whatever the technology could not be adopted in large scale, actually. There are some solar cook stoves with storage also, but the cooking and storage is out of the house or on the rooftop. So again, we have to go there on the top and cook whenever it is there. So there is no control on cooking power. See, whenever whoever is cooking will be knowing very much. We have to control the cooking depending upon the dish and depending upon the time. Actually, so in solar cookers we don't have any control. Actually, it will go as per the solar radiation. Actually, so then it gives a restriction on what type of meal being cooked on the solar cooker, particularly concentrated cookers. So because there is no control on this. So there is a lot of inconvenience in cooking when compared to LPG and CNG stove. That is the reason the solar cookers could not take off very well, actually. Both the things, box type and the concentrated cookers. So this is the view of a box type. Many of us, as I told, 1980s and 90s, This was very popularly used. Popularly means many people were used. There was some policy and program was there. There was subsidy was there. But after that, this was vanished actually. Nowadays, not much we cannot see. Here also, we have to keep the things in the food in to cook in the vessels and close it. After 2 hours, 2.5 hours, the rice or whatever the vegetables got cooked actually. And this is one of the cooker. We can see this is a concentrated type cooker kept outside. As I told earlier, it's near the stove. So people have to come out and cook in the stove actually. So in addition to the cooker, people also have to stand on the under the sun actually with the heavy radiations. So different type of concentrated solar cookers are developed because a lot of research has been done in this also. You can see that 2 to 3 type of cookers in this area. And but as I told earlier, one has to stand next to the cooker and work on this thing actually. Here also we can see so already it is concentrated, right? This place will be very hot, but still people has to put the vessel and cook it. So these inconvenience acted as a big barrier to take up the concentrated solar cooker actually. So this is the new, the proposed solar cooktop with thermal storage, actually, with the hybrid thermal storage. In fact, why I told hybrid means I will explain it later actually. If you see the components here, the solar cooker, the concentrated parabolic collector is very much existing actually. It's a similar one to what we have seen earlier in slides actually. And the receiver is modified here. There is a 2 loop of thermic fluid in this one. Actually, one loop is since to transfer the heat from the solar concentrated receiver to the storage system, and again another thermic fluid loop is here, which is to transfer the heat from the storage system to the cook pot section. So this here, what happens is in the daytime, the solar energy is received here and it's stored in a storage medium, actually, thermal storage medium. There are several storage like thermic fluid or any other thing. There are many materials that I will get back later. So there is a storage system here. So, and the thermal energy is stored here, and a small pump. There are 2 thermic high temperature thermic fluid pump is there in the system. A small pump will be circulated whenever we need the heat, because in the daytime this pump will be on to get the energy into the storage system, and whenever during cooking time this pump will be on the right hand side to put the energy from the storage tank to the cook pot actually. So that's how the system works, and this system will be in the kitchen actually. That is the maximum, that is the key difference between the other solar cookers and this solar cooktop. Solar cooktop will be in the kitchen, and this also will be having 2 controls. We can have the power control here. If we want more power, we can increase it, and when we want less power, we can decrease it, kind of. So the power is in our control. We can cook at any time. At the same time, this is in the kitchen actually, and completely clean cooking, no smoke, no pollution. So either in the kitchen or out of the kitchen actually. So it's one of the best option available. And right now it is in the development stage. I have not, I've studied a lot, and no other is working in this type of cooker actually. And there should be good encouragement particularly, but everything needs fund again to do this type of concept actually to work. Because when we talk about a net zero achievement in so and so year, and with the existing technology and with the existing product, this is not possible actually. And the gap between the target and the achievement will remain larger. So we have to think about what are the new technologies to be getting. At the same time, what all the new product has to come actually. So the products and technologies should be adaptable actually by cost wise and the convenience wise for the people to use it in a large scale. And when we say the status actually, again, it is not the new one actually, either the storage in the thermic fluid or the things, but here I propose hybrid storage and or the concentrated. Everything exists. if you see that left-hand side, there is large dishes, and this is most of the places, even in India, it is used for the community cooking. And the right-hand side, if you see that it's a solar tower, actually. There are several mirrors reflects the radiation to a concentrated place, and there is a storage system, actually. Either there is different type thermic fluid or molten salt. So it is stored, and its the power is given for the 24. Here in this presentation, what we are emphasizing is use the existing technology at a scale down level for domestic application for cooking. So concentrated cooker and a hybrid thermal storage and cooktop. So that is the one. Basically scale down the technology for domestic and individual application, and design the solar cooktop as per the requirement, depending upon the cooking applications. Here, when we go for that hybrid thermal storage system, what are the choices available? Why hybrid, actually? Why not use? Because right now, the mostly what people use is either thermic fluid or the molten salt. In molten salt, what happens is the salt has to be kept in the molten form around the clock, actually. Suppose if 4 or 5 days, if there is no sun means, then the molten salt is heated through external electrical sources or external energy input to maintain it in the molten form. Because once it is solidified, that's all. Then the system has to be restoring is not that much easy, actually. So when we see the storage medium, one is thermic fluid, and another is the molten salt. Sand, dry sand is used, and sand with wet sand also used for depending upon the temperature application and all, and stone chips, gravel or stone chips, and some people use even graphite for the storage. So these all are there already in use in a different form. Maybe 1 or 2 plants, they are not very much popular. For example, in Italy, Sicily Island, I visited one of the power plant. There they use sand for dry sand for the thermal storage, actually. The sand is raised to 700 degrees centigrade, and the water is passed through the hot sand and to generate steam, and steam is used for power generation. It was about a 500 kilowatt system. So these all are the technologies available. What is needed is use the best combination of thermal storage material for cooking application as a designing and using in this thing. For example, the thermic fluid, if you see that right hand side, there are several called density, heat transfer rate, operating temperature, specific heat capacity. So these all are the 4 influencing factors of the to select which thermal storage medium we have to use, actually. But what happens is everything has its own properties. Some of the, for example, sand, if you take, it's more than it's 2080 kg per meter cube, and its specific heat is somewhere around 1400, actually. And its operating temperature also quite high. It can be operated around 700 degrees centigrade, actually. Whereas thermic fluid, if you see, which is the one popularly used now, it cannot go beyond 350 degrees centigrade, and its specific heat is 2950 joules per kg per degree centigrade. So we need maximum specific heat capacity, at the same time maximum density, actually. That's how the energy density will go up. So in that case, we have to use the combination, either a liquid and solid medium, actually. That is the one thing. So which one has to be used? How means that depending upon the cost and the other factors, cost and the heat transfer factor. These 2 factors which we have to see and to decide on this thing. So combination. For example, if you see the thermic fluid, plain thermic fluid, which will be having 1500 to around 1500 joules per kg per degree centigrade. But if they add a nanoparticles materials 2.5% by weight, then its specific heat goes almost more than double, 3250 joules per kg per day. So that's where I am telling you, we need to go for a hybrid storage system. Right now, a lot of work is being done on the adding nanomaterials in the thermic fluid, because we cannot add too much solid particle in this thing, because otherwise the flow of thermic fluid will be affected. So what is the ratio to be added and what to be added? So this designing of hybrid storage system is one of the key part of this solar cook part basically. So because once when we have that the best storage system, it enhances the cooking options, cooking at any time, any meal kind of this thing. So, and it increases the convenience also. So just now I have talked about more about this hybrid thermal storage. If you see the cost part actually, see when the cost of sand is ₹4.5 per kg, the cost of thermic fluid is ₹250 per kg. Imagine almost 50 times, more than 50 times higher actually. And both of the thing can be used for thermal storage. We have to see the fractions, the combinations, how to use these things. Excuse me. So energy cost by using sand is works out to be like this: ₹16 per megajoule of energy storage. Energy storage cost by using thermic fluid is ₹476. So depending upon the energy requirement, depending upon the heat transfer rate, we can arrive a combination of these things. So that is the key message of this slide particularly. And as I discussed, density of sand is 1800 kg per meter cube, and density of thermic fluid is 860 kg per meter cube. So so it should be a high, the density should be high, at the same time specific heat also should be high, cost should be lower. We have to consider all the factors when designing the hybrid thermal storage system. To summarize the features of the solar cooktop, is there are several features. The solar cooktop will be in the kitchen, like LPG or PNG cookstoves, and clean cooking, and without any emission. The solar energy receiver will be on the rooftop, or can be fixed on the south wall, like the TV dishes actually. The thermal storage system can be located either in the kitchen or on the rooftop, depending upon the convenient. It can be put anywhere because there are two pumps which is transferring the heat from the thermal storage to the cooktop. Solar cooktop can be used for two vessels cooking at a time as LPG stoves. Power input can be varied as per user requirement. Cooking can be done anytime, as in case of LPG, PNG cookstoves. No need to cook only during sunshine hours. Cooking can be done, that's what I told, that anytime, any meal, no restriction on the type of meal, and comfortable in cooking as LPG and cookstoves, and can have more user acceptability unlike other solar cookers. So whatever the challenges are there associated with the existing solar cookers, solar cooktop overcomes those challenges actually. Suitable to use for urban as well as rural applications. And the way forward is like this: encouraging and target-oriented policy like e-cook stove should be there in place for large-scale use of solar cooktop. Support for product development and demonstration. See, the product development demonstration, both are very important. Everything cannot be done by the private companies or private parties. Somewhere the government policy should be embedded, some of the financial support also. And there should be more demonstration systems so that people see and believe and buy kind of this. And then the conclusion, we can see that the choices and where do they stand. Solar cooktop is the best option among the available cookstoves for clean cooking actually. If you see that clean cooking means, one is the electrical cookstove by PV, and another one is LP, the solar cooktop. So these two cookstoves are clean cooking really, because electric cookstoves using coal power, we cannot call it really. It is a clean cooking in the kitchen, but not it pollutes somewhere else in the power plant actually. So the two cookstoves here is, one is the electric cookstove by PV, another is the solar cooktop. But solar cooktop has many advantages for the PV, because the storage, batteries has to be replaced, and the cost wise everything, because solar cooktop can be designed competitively with the cost of that PV based electric cook system. Thank you very much.
Yeah, thank you very much. It was a very vivid, description of the entire clean cooking sector. The way you covered all the devices and finally focused on this thing. But this thing is that this system has to be cost effective. Don't you feel that cost will be a major factor? We have so many, those mass cooking, we have using the Arun dish. Even Akshardham has it. If you can see other places also, we have thermal cooking is there on a mass scale. But for domestic, don't you feel the cost will be a big factor?
The cost will not be a big factor because right now there is a lot of new technologies has come for that dish part, particularly FRP dishes and all. So and the storage medium also, when we go for hybrid thing, that will reduce the cost particularly. If you rely only on the thermic fluid or molten storage, this kind of this thing will be having a large cost. But using a hybrid thermal storage will reduce the cost a lot. It will be much competitive. Particularly, I don't see, because solar PV based thing is coming around 70,000 per cooker actually, but this will be coming because my estimation actually, because I have not gone too much in the cost part, but it will be much less than that one actually.
So this project you are doing on your own, or is it supported by some government this thing?
Right now I'm working on the modeling. There is no support on the government side, but looking for support actually, because this, in fact, this type of project doesn't need much cost also. If you see that, I think comparing to other large like hydrogen and all.
Clean cook stove program has been done away with the government. They are now looking at solar done, and I feel that is correct also. See, how much can you support? It is a device which the government has supported for so many years. I think 83 to 2001. It's almost 2 decades it went on to, more than that. So there's no need. It's a small device, everybody will cook. And if they make it in a better way, it's okay. But these devices are something which need to be promoted. I think
that's what, when the new technology, new product comes, which has a large impact on the climate and the cleanliness. There some support can be provided. That's what my...
But you didn't the mini stove, which you, mini moto, which is there, that is also a tier 4 stove, no?
No. So far, biomass stove has not reached the tier 4 part actually.
Okay,
but this will come, I think. But so far, I have not tested it actually. The stove is ready. Some experiments I'm carrying on. Maybe somewhere I get it tested. But I am also having a long confident on that this will reach the tier 4 one actually.
Okay. And we had BioLite, the TEG stoves. I don't know. I don't see any mention of the BioLite in your, because IIT did a lot of work on TEG stoves.
See, BioLite, you must be knowing that BioLite, I worked a lot with that one actually. And any of these post-draft stoves gives the particle matters are quite high, but you will have that CO is less at that PM 2.5 will be quite high because of the first draft actually. So that is applicable for the BioLite also.
Okay. Because I've lost some connect with the manufacturers and all that. Though we did a project, as I told you, for this Haryana villages where we could promote biomass stoves did not find so much of acceptance. So the electric induction cooking, because it's a supplement to the cooking. And in case in what you said about solar cookers, that was one of the problems. In fact, carrying it out, and even you can't cook all type of meals. That is also there. I had a friend who bought it. She says, I put my dal and sabji in the morning and I go to work. Evening and I come and remove it and then I...
It was like that,
So that was not finding a lot of favor. And it's good that the government, it's okay. If the product finds a market, then only it has to find a market. How long the government can support? So that is the... And this solar-based, what you said about ESSL, I think they are going for carbon finance. They are going to put up a project for carbon finance where Ministry of New and Renewable Energy is also going to support this solar, solar DC based cooking, DC electric cooking. That is there. But you should write a proposal and project to the ministry. I think they will give support for this hybrid storage also.
Already I submitted one last year. There was a call. After that, still in processing.
Okay. Processing takes time. Be patient.
One is submitted already.
That's good. I think so. So I should.
Thank you very much.
Thank you very much. It was a very, the whole sector was covered so well. And of course, I also got updated with the latest products. And I wish you all the best for your project.
Thank you very much.
And of course, it is a good dissemination. It will be a very good dissemination. Every household. And sun is the source of energy. It is always there. So tapping it in the right manner, I think so your product will
That's right.
That's that is very important. And you've given all the scientific parameters, how it works. I think so it should be. Only you have to convert it into a product and then bring it to the market. That is very important.
True.
So once again, thank you very much, and thank
Thank
you
you.
for
Thank you,
giving us
ma'am.
an opportunity. I would request Mr. PB Singh to kindly give the formal.
Ma'am, any
Thank you.
questions from audience?
I think there is no question. Yeah,
Yeah,
I couldn't see any.
anyway,
Yes.
yeah.
Yeah.
Okay, thank you, ma'am. Thank you very much. Thank you, sir, Dr. Raman, for
Thank you very much.
excellent presentation. It's a very informative and knowledgeable. You explain about different type of cooking stoves and benefits of the use also. Hope all the participants are get benefited. Once again, thank you very much, Dr. Raman. Thank you,
Thank you.
sir.
Yeah.
Thank you.
Now I would like to thank all the participants for their valuable presence and support. Your presence is provided motivation to the speakers and all of us. Thank you very much, all of you. Thank you.
Thank you very much.
Thank you. Have a good day.
Thank you, sir.
Thank you.
Thank you, Dr. Raman.
Thank you very much.